Hello, we are discussing about GATE 2011 ECE paper. Look at the unity negative feedback configuration given, okay, with a plant transfer function h of s as 100 by s into s plus 10 whole square. Which signal flow graph that doesn't model the plant transfer function h of s, that we need to find. Okay, even though it has given a closed loop system, but the signal flow graph is related to h of s only. It is not related to entire closed loop system. It is only related to plant transfer function h of s, that you can observe from this one. Output of this one is y, input of this one is u. So everywhere the signal flow graph is between y and u only at any case. So simply which signal flow graph is going to be not representing h of s, that you need to find out. So out of this 4, 3 will represent the h of s and 1 will not represent the h of s. That one we need to find out. That will be the answer. Okay, so generally we can obtain in a reverse manner. Okay, instead of drawing this one into signal flow graph, because there are signal flow graph, you can write it in a different manner. So we will go for the reverse process. That is, we are going to obtain the transfer function from the given signal flow graph by using Mason's gain formula. By using Mason's gain formula, we can obtain transfer function from the given signal flow graph. So we know that this formula is going to be sigma. For each value of I, we are going to calculate pi and delta I divided by delta, where pi is nothing but path gain in the ith forward path. That I represent is nothing but ith forward path. It may be consisting of any number of forward paths, and we are going to point out one corresponding forward path. In that one, what is the total gain, that is representing pi. And this delta can be calculated, this denominator delta can be calculated as 1 minus sigma of, that is sum of sigma of individual loop gains. Sum of individual loop gains, plus sum of product of two independent loop gains. If you find any two loops which are independent of each other, they are not touching, they don't share a common node, then you are going to get the product of those two loop gains, and that will be your writing over here. So simply you can write like this: sigma is equal to 1 minus of L1 plus L2 plus L3, like this. Next, plus if they are independent, then you can write it as L1, L2 are independent, and L2, L3 if they are independent, you are going to get the product of both the gains. And you are going to write in this way: plus dash 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 how many number of independent loops are there in the given function. This is what Mason's gain formula says. So this delta I is going to be similar to delta, but where you can ignore the loops which are connected to that ith forward path. The loops connected with ith forward path will be neglected. Then it will be similar to calculate delta, that is nothing but gives the delta I value. Delta I value is same as calculation of delta, but you have to ignore the loops which are connected to that ith forward path. So this is what theory behind the Mason's gain formula, how to calculate. Now from this h of s, I want to write it in Mason's gain formula form. So h of s is equal to, I can write it as 100 divided by s into s square plus 10s plus 100, and that is equal to, you can write it as h of s is equal to, and this you can write it as 100 by, next 100 divided by, next if you take s square common, then it will become s cube into 1 plus 10 by s plus 100 by s square. We need to write 1 plus something. Okay, since the delta denominator is going to be consisting of 1, that single one we need to get. So h of s is equal to 100 by s cube. Okay, s cube I am taking into numerator, so this will be 1 minus half. Okay, minus 10 by s minus 100 by s square. Now it will be showing that one h of s is consisting of at least two loops that may be independent or not independent depending on the gains, you can say. Okay, so there must be two loops. One is loop 1, the other is loop 2. Two loops must be there. Whether they are independent or not, that we are not bothering right now. Okay, because the gain is going to be giving that information. Gain also takes part while going through that information, so we are not bothering about that one. Now whichever signal flow graph is going to be having two loops, that will be modeling the given transfer function h of s. Whichever is having more than two loops or less than two loops, that will be not modeling the h of s. Okay, now look at this one. It will be consisting of two loops a. So this is modeling h of s. And if you are observing this one also, this is first loop and it is second loop. Okay, it is going through this way. So this is first loop and it is second loop. So this is also models the h of s. And here also this is first loop. Okay, and it is second loop. This is first one and it is second one. So this also models the h of s transfer function. Now if you observe, it consisting of only a single loop. A single loop, okay, will be giving a 1 plus term, that's all. Single loop is going to be giving a function which is nothing but 1 plus a loop gain. That will be the given function in the denominator. So you don't get this one. This will not model the h of s. So the right answer is D. D is the right answer for this question. And you can check the h of s implementation from these signal flow graphs using Mason's gain formula by going through this equation. Okay, I verified this one. So you will also get the same function h of s from these three loop gains. You can do that one, but this is a simple fact. You can obtain the answer from this way. So the right answer for this question is D, and we are not stopping it. We are going to continue the second one because it is a common data question. Okay.